Alright guys, welcome back. Today I'm going to show you three different things. One is a Kaggle.com dataset. So Kaggle.com is open data repository where people upload their own dataset and um, share their codes to analyze the data sets and things like that. So there are a lot of interesting data sets available on Kaggle, which you can freely use to hone in your data science skills. The second thing is web scraping. So we're gonna talk about this technology called a Beautiful Soup. So Beautiful Soup is a Python library that allows you to systematically analyze a web sources. So it allows you to um, access the HTML elements of a web page using Python codes and then automatically process them. So it's going to be pretty useful skill for data mining. And then the third thing is we're going to see one of those APIs for accessing an existing data set. So all three of those skills are going to be very useful for you to collect information from the internet and then process them and then produce your own data set for your own analysis. So to get started, let's first take a look at the Kaggle.com dataset. So Kaggle.com, like I said, is a website where you can browse a lot of different data. So this is how Kaggle.com website looked like. Of course, you need to sign up and then create your account. Now, if you click data, then you can see this data sets that's available on Kaggle. All of them are free. So it says it's total 55,000, almost 56,000 data sets available as of now. I'm just going to click one of those data sets. And as you can see, this is the data set page. You can see the brief description over here. It shows what's in the data set and what kind of parameters are available and the explanation of the parameters and so on and so forth. And then in case of this data set, we have only one CSV file like this. And then there's a preview of the CSV data set. You can see that there's an age column, sex column, the chest pain type column, so on and so forth. And then you can kind of see what's going on over here. So using the download button, you can directly download the CSV file. Let me try to click some other data sets. So this one is NIH chest X-ray data set. This is pretty popular data set in medical imaging. So it's a data set comprised of 112,000 X-ray images from 30,000 unique patients. And in case of this data set, the things are a little more complicated. So it contains all those images as well as a CSV file containing metadata for each of the patients. So as I scroll down here in the Data Explorer, you can see there are 42 gigabytes of data. So it's a quite big data set. And you can click around and see what's in each of those files. In case of images, folders, obviously there are images that's available in this data set. So we have lots of PNG files. There are also CSV files that contain some metadata about those images. So you can see that there's an image file name, and then for each of those image file name, you have the label of the disease. We have the bounding box describing the disease location and so on and so forth. So Kaggle.com in a nutshell is a website where they host this kind of an open data sets to provide some resource for data scientists, and then to incentivize people who are uploading this kind of data set. They actually host this kind of data science competitions. So for example here, RSNA is the Radiology Society of North America. They host this pulmonary embolism detection challenge. There's even a prize money, $30,000. So if you click on that, you can see that there's a description of the competition, how they plan to evaluate the performance, what's the timeline, how much is the prize money, and so on and so forth. So, through this kind of, creating this kind of an ecosystem, the philosophy of Kaggle is to, make data science more popular and accessible to, a lot of different people. So this is a great data set if you're interested in studying data science on your own. Now, what I'm going to show you is, of course, you can, for example, let me go back to NIH's X-ray data set. So, of course, you can just download a data set and then, download the data set on your local computer and then upload it to Google Colab, and you can go from there. But obviously, if you think about the problem, we have in this case 42 gigabytes of data. So downloading 42 gigabytes of data to your local computer and then sending that again to Colab and so on and so forth, it's going to be a lot of inconvenience per se. So what I'm going to show you is a way to directly download the data set from Kaggle to Collab. Okay, so if you sign up and log into Kaggle, on the top right corner, you're going to see this your profile page. Now, if you click this icon over here, you'll see this pop-up menu. What I'm going to do is to click My Account. So as you scroll down a little bit, you're going to see this Kaggle API, create a new API token button. So this is API key that allows you to log on to Kaggle dataset and then get an access to the dataset to download data. Okay, so what you're going to do is to click this Create New API Token button, and then soon it'll download a Kaggle.json file in your downloads folder. Okay, now let's quickly jump onto Collab environment. Okay, so here what we're going to do is to load that Kaggle.json file to the Collab machine. So in order to do that, here's a simple trick that you can use. So from Google.Collab, import files, and then files.upload. So that's a function that provides an user interface that allows you to upload a file. Sorry, I forgot to put S. So files.upload is a function that provides you this kind of graphical user interface, which you can use to upload a data set or whatever file, in fact. So I'm gonna just click that Kaggle.json file, and then now it says upload is 100% done. There's total 67 bytes, and then saving Kaggle.json to Kaggle.json. So let's just check if Kaggle.json file is available now on the Collab machine. Now, as a result of typing this ls command, remember ls command is to list all the contents of the current folder. And you can see in the current user folder, we have the Kaggle.json file. Okay. All right, what I'm going to do now is to create a folder that Kaggle API is actually looking for. So mkdir is a command to make directory, make dir. So what I'm going to do is to create a directory called .kaggle under the user home directory. So in Linux, the tilde sign over here is a shortcut to indicate the home directory of the user. So that's where all of your personal stuff is configured in Linux. So I'm going to create a .kaggle directory under that user home directory, and that's what Kaggle API is looking for. So you need to put that Kaggle.json file into that folder. Otherwise, Kaggle API will not be able to find the Kaggle.json file. So the next step, obviously, then is to copy Kaggle.json file into that folder that we just created. So that's going to be the CP command. So copy this file and then create this file over here by copying it. And then finally, here's one last step, which is to change the user access right. So by default, Kaggle.json file is not accessible by external APIs. So in order to give a permission to Kaggle API to access this Kaggle.json file, this is the command that I'm going to use to change the user access right of this Kaggle.json file. So I'm going to run this cell, and then as a result of that, well, in fact, nothing shows up because everything was successful. And at the end, what you should be able to do is now to install Kaggle API by calling pip install Kaggle, okay, and then that's going to install the Kaggle API on Google Colab. In fact, it seems like Google Colab now start to come with the Kaggle API by default. So it says the requirement already satisfied. So you didn't actually have to call this pip install command, I believe. But anyway, good to know. Okay. Now, now that we have the Kaggle API installed on Google Colab, here's the command to, for example, to list all the data sets that's available in Kaggle. So by calling exclamation mark Kaggle datasets list. So this is the command to list all the data sets that's available on Kaggle.com. I mean, obviously, it's not going to list all the 55,000 data sets. So it's going to show some, only a few examples here. Here's another command to download the data set. So let's say once you, let's try a real example over here. So one of my favorite data set that I use as an example in the classes is the avocado price data set. So this is the data set where people collected the price information of avocados every day. So you can see that there's a huge CSV file that shows the average price at each different date, as well as the total volume of avocado sales, and so on and so forth. So we're going to try to download that data set. And what's important in order to download this data set is this URL over here. So under www.kaggle.com, you have slash some user ID slash the data set ID. Okay, so that's the URL structure of Kaggle.com. So what's important is to download this data set. What's important is this part. So let's assume that it doesn't have to be avocado data set, whichever data set you want. Let's assume that you ended up in data set page like this. And what you're going to do is to copy this part of the URL structure. And then we're going to, use a command to download. So instead of list, I'm going to type download. And then -d is the, tag to specify the source of the data set. So this is where the URL structure that you just copied should go in. So Kaggle datasets download /-d Neuro Music / avocado prices. So that's the location where the data set exists. And let's say I want to put that into a folder called data. Okay. So then by running this command, what this Kaggle API will do is to download the data set from this source over here. and then we'll create a data folder inside of my Collab machine, and then put the downloaded result into that folder. So let me see if everything is done correctly. So now you can see the data folder created as a result of running this command. And if I try to look into the data folder, you can see that the avocado prices.zip file has been downloaded. Okay. So after downloading the zip file, obviously the next step is to unzip the file. So for that, unzip is the command I'll be using, and it's under avocado. It's under data folder, and then the file name is avocado-prices.zip, and then I want to extract that file into the same data folder. Okay. So as I do this, then you can see that it's inflating the archive, avocado prices.zip. And as a result of that, here you can see that avocado.csv file has been created as a result of unzipping this zip file. So in this case, this is a simple data set that contains only one CSV file. So nothing exciting happens, when you unzip the file. But in case of, for example, the NIH chest X-ray data set, after unzipping the file, you're going to see obviously a lot of different files in the data folder. So then, after this, you know the drill, right? So after this, we learn how to load up a CSV file from, Apache Spark, and simply what you need to do is to read the CSV file using Apache Spark, and then do the analysis, in whatever way you want. Okay. So that was a brief explanation of how to use Kaggle in the Collab environment. So the reason why I'm introducing this is because, like I said, Kaggle is an excellent source of data for data scientists to hone in their skill. So there are lots of different data sets, and whenever you have a machine learning model or a hypothesis that you want to test, Kaggle is probably, one of your go-to places where you can find a suitable data set and then, try out your algorithm. Okay. Now we're going to move to the next step, which is to use a Python script to scrape a web page. And in order to do that, I'm going to use a website here, flycid.com. So this is a website of Eastern Iowa Airport, Cedar Rapids Airport, and this is where you can find the flight status information. So as you can see, I have a live update of what kind of flights are arriving at the Cedar Rapids Airport, and the flight number, the city, time, the baggage claim, the status of the flight, if it is delayed or on time, and so on and so forth. So this kind of information is available on this website, and what we're going to do is to create a Python script to access this information over here, and then produce a data table accordingly. So in order to do that, what you need to open is a code inspector page. So in case of Google Chrome or Firefox, if you hit Control-Shift-I, or just right-click and find the Inspect menu, then it's going to open up a window that looks like this. It looks kind of scary, especially if you're not familiar with HTML or web languages. But this is basically a window that shows the source code of this web page. So this is a useful tool for developers, but also for data scientists, because it allows you to graphically understand what's going on this website. And then what we're going to do is to inspect the HTML elements to find, where the information is located. Okay. So for this tutorial, by the way, I recommend you guys to use either Google Chrome or Firefox because for the other web browser, there might not be a capacity for you to look into the source code and things like that. So as far as this exercise goes, I recommend you guys to use Google Chrome or Firefox. Now, here, you probably realize that as I move my mouse cursor, you can see that not only the code line over here on the right-hand side of the window is highlighted, but also on the left-hand side, some elements of that of that web page is responding, right? So as I move my mouse cursor to a different location of the source code, you can see that the corresponding page is highlighted. So this is one way to find where the information is located. So in this case, as I move my mouse cursor, I figured actually there's a section tag in HTML. It says section class something something. And as I move my mouse cursor to this section tag, you can see that the main data table over here is highlighted. Okay. So, and then you can narrow down your search by opening the hierarchical structure of this section tag. Under this section tag, I found this div tag, right, which highlights again the data table that I'm looking for. And then I can open up another div tag under that div tag, and I can kind of narrow down the search. And then as I keep doing that, there are lots of div tags, and here at the end I came to this final iframe tag. So for those of you who are not familiar with the HTML, in a nutshell, iframe tag is a tag that people use to embed an external web page into another web page. Okay, so it is like a picture-in-picture kind of thing. So it seems like Cedar Rapids website, Cedar Rapids Airport website, does not really host this information directly from their own server. It seems like they're just mirroring some external web source and then display that within their website as if it's part of their web page. So under this iframe tag, you can see the attribute called src. So that's where the source is located, and then you can see this URL over here. So if I copy this address and then put that in the web browser, and there you go, I have the same table from this previous screen. So that's actually the one that I'm looking for. Okay, so I'm gonna go in further and then inspect this page as well. So inside of this page, again, there are a lot of different things going on over here. So I could keep click and narrow down the search and then try to figure out what are the HTML elements that correspond to the flight ID, what are the elements that correspond to the city name, and things like that. But that's gonna be a little kind of painful, right? It's not very convenient. So for those cases, actually, there's an icon that you can click over here. Okay, there's a box with a little mouse cursor on top of it. So you can click this, and then now your mouse becomes an inspector. So as you move it around, you can see that the corresponding HTML elements is highlighted like this. So now what I'm going to do then is to try to click this table, or maybe just let's click this city header. So as I click this one, it shows the corresponding location of the source code that correspond to that column that I just highlighted. It seems like it's a part of this table tag. So table tag is obviously an HTML tag used to create a table. And then under the table tag, in fact, we have t-head and t-body. So t-head is a tag for defining the header of the table. So obviously, as you can see, as I put my mouse cursor on top of this t-head tag, you can see that the header of the table is highlighted on the left-hand side of the screen. And as I move it to t-body, you can see that the main body of the table is highlighted. So that's where the information lives in, right? So from t-head tag, we can, access the column names of the table. So as you can see, airline, flight, city, time, claim, status, those are defined under this t-head tag. And as I click t-body, you can see lots of tr task. And tr task, it's a table row tag in HTML. But even if you don't know what it is, obviously, as I move my mouse cursor, you can see that the different rows of the table is being highlighted. So these are the elements that I would like to scrape, right? And under each of the TR, you can see a lot of TD tags. So TD tags are the ones that, oops, what happened? TD tags, there you go. TD tags are the ones that defines the table items, okay, of the table. So for each of the TR, so we now have the anatomy, right? So the table is comprised of t-head and t-body, and t-body is comprised of a bunch of table rows, and each of the table rows are comprised of TD tags containing the table items. So these are the information that we'll be using to scrape the information from this airport website. Okay. Now let's go back to Google Colab. I'm going to just continue to use this same Colab notebook. Here, what I'm going to do is to import requests library to get the HTML page, okay, from that URL. So requests.get is a function that allows you to get the HTML page from a certain URL. What I'm going to do is to copy this URL from that page that we just saw and then run this command. And as a result of that, the request library returns an HTML page. So if you, for example, print page.content, then you will see that the HTML source code is printed out like this. Okay, so we can see that part of the table. It is not, user-friendly in terms of, how this thing is printed out, right? But it does seem to contain all the information that we're looking for, so that's good. Now, excuse me. Now, what we're going to do then is to actually parse this HTML page by removing all this unnecessary information and remove all the tag codes. And then we're going to extract only the portion that we're interested in. And that's where the library called the Beautiful Soup can come in. Okay, so Beautiful Soup library can be imported from this thing called the BS4 library. And BS4 library is that module is already a part of Google Colab, so you don't really have to install anything. Now using Beautiful Soup, I'm gonna create. I'm gonna parse the contents of the page that we just loaded up. And to do that, we're going to use HTML parser. And that is going to create a variable called soup that contains a parsed page content. Now, the difference between the raw page content and the parsed page content is that now things are fairly nicely organized so that we can For example, prettify is a command to print out the HTML content in a way that is more readable. So compared to this one gigantic line of bunch of HTML codes, now we have something that is more readable, right? So the tags are nicely indented and then separated by lines and things like that. So it became more readable compared to the previous example. So that's what Beautiful Soup does. Now, using this, now that the HTML codes are parsed, it is really easy after this. For example, we know that from this web inspection tool, we know that the information lives in this table. Okay, so what I'm going to do then is soup.find. So soup again is the Beautiful Soup object that contains the parsed HTML contents. And then there's a function called find, which you can simply, find an object, okay, from the HTML page that you just parsed. And there you go. Here's a command to find a table. And then I just printed out the contents of the table. But hold on a second. It seems like the table that is printed over here is not the one that I was looking for. Okay? And that's because, in fact, the HTML page has a lot of different tables. It's, there's no reason for you to assume that this is going to be the only table that's available in this web page. There are, in fact, many other table tags somewhere in the HTML page. Let me try to find where it is. Not here, but there's got to be a table in this web page. There you go. Yeah, you can see that. So in fact, this arrival departure menu and then the search window is part of a table, because table is a method that people use to kind of lay out a web page in a nice, organized manner. And that's why, there are multiple, table tags. So if you just, soup.find table, then what Beautiful Soup is going to do is to find the first table, okay? So it will read from the top of the HTML source code, and then whenever it encounters the first table tag, that's going to be the one that Beautiful Soup is going to return, okay? So you need to be a little more specific. So one of my favorite ways to be more specific is to actually provide an information about that table by specifying the attribute. So let's try to find that table again. So here we go. So right next to the table tag, you can see there's a class, okay? And, class attribute is what people use to specify the layout and the style of that particular HTML element. So that's, what, web developers prefer to do by assigning class to different tables and then treat them differently in terms of applying, styles like color, font type, and, things like that. So what I'm going to do is to use this information. So the class is views-table spacebar cols-5. So that's that's a class name. I'm gonna copy this, okay, and then paste it over here. Now the way to specify the attribute is by using curly bracket, and then inside of that you can make a dictionary of attributes that you want to further specify. So what it says now is I want to find a table, but not only that, I want the ones that has a class attribute that is view-table cols-5. Okay, so if I do this, then there you go. Here's a table that I'm actually looking for. The table that contains the airline information, the flight, city, time, claim, status, and so on and so forth. So you can see that you know, the real-time information is being retrieved like this. Of course, you know, this is only the table, and we don't have yet anything more specific than this. So, but you know, the workflow is kind of, you know, pretty much the same. So table is another beautiful sub object now. You know, what I'm going to do is to keep finding, okay? Keep finding the element of the table. So obviously, well, I should have not cleared up the screen. So obviously the next level in HTML element is tbody, right? So my strategy is to, you know, first of all, to find a table that, you know, contains the information that I'm looking for. And then, you know, I'm going to further find the tbody tag in order to find the main body of the table. And that's going to be table.find tbody. And in this case, I don't really need to specify anything else than this because there's only one tbody under table. So I don't really have to, you know, specify something like this. So I can just simply go like this and print tbody. And as a result of that, you can see that the main body of the table has been retrieved. So now you kind of get a sense, right? So after that, you know, tbody.find, the next is table row, right? And there you go. Here's the table row, and that's gonna be my tr. And then, you know, after that, tr.find, td, and so on and so forth. So that's kind of a, you know, workflow of how you can access to the information. So let me actually just show you. So after doing this, if you print td, now we're getting closer to the information that we're looking for. So in this case, this is a URL that shows the location of the airline logo files. So you know, we came closer to the actual data contents over here. Okay, but you know, you may wonder though, if the find function, like we saw from the previous cell, if the find function only returns the first element out of the list of elements, okay, how do I access to the next table row, right? If I just call tbody.find tr table row, then it's going to only return the first row of the table body, right? Rather, I would actually want to have an array of table rows so that I can access all the contents of the table. So for that, it's actually pretty simple. Just add find underscore all, okay, and run the command. And as a result of that, it's going to return a list of table rows. So I don't know if you can notice this, but now we see the square bracket indicating that tr object here, tr variable, is a list, is a Python list, okay? And then you can see there's a comma separating each of the table rows. So for example, now, you know, something like this is possible because tr now is the table row, the Python array object, Python list object. Now, you know, this is the third element in that list object, counting from 0, and that's an airplane from Charlotte. So let me go back to the web page, and here, 0, 1, 2, 3. Yes, that's the plane from Charlotte, right? So that's basically the way that you can retrieve the information. Then, you know, instead of manually going through all the rows, now I can use a for loop. So for I in you know, the length of the list tr, right? Now I'm going to then, for example, ith element of the table row. So in that way, you can print everything over here. Of course, this is not the final form of the information that we're looking for. We are actually looking for tri dot find all td, and that's going to return a list of table items, right? So in a similar logic, we're going to create another for loop inside of that for loop, and that is going to traverse around the TDs, right? And here, let's just try to simply, for now, print the jth element of TD. And then after that, let's try to put a line to visually split the result. So there you go. This is much better than before, right? So as you can see, we have the information that is split by the lines, like this, and then you can see that the contents of table items are here. I can do a little bit more work to make it look better. So for example, now we kind of strip down to the information, to the level where we don't have any additional tag, HTML tag surrounding this information. So then after this, we could actually just call contents, okay? And then the contents tag, the contents method actually returns a list of contents. So in this case, we have only one contents in each table TD tag. So we only need the 0th element of contents. So by doing this, it becomes actually much cleaner, right? In terms of the information here. So that's, how you access to the information that you're looking for. So in case of the 0th element, now a blank is displayed, and that's because, well, let me roll back to the previous code. That's because, in case of the first item of the cell, there's a image tag that contains the URL of the logo file. So we actually have another layer of HTML tag you have to strip off. So that's why if you just call tdj.contents, you don't see any information for the 0th item. Of course, you can repeat this procedure, and then, I could probably just add if j equals to 0, then do this, otherwise do that. But, I'm not going to show you all that because I don't think that's, necessary. You probably should be able to extrapolate what you just learned and then apply to further parse the information. So, yeah, so that's basically how you can use Beautiful Soup to parse the information and create an array of the things that you're looking for. And obviously, the next step is going to be to then create a, Spark data frame, and then, using this type of for loop, you can add the contents to the Spark data frame, and then, build a data table. But again, that part of the work is quite straightforward. So I think showing this to this level is going to be enough for you to kind of connect the dots and then, apply the techniques to collect information from the internet and, create your own data set. Okay. So of course, in this example, I just used the Cedar Rapids Airport website, but many other websites are more or less the same. So all you need to do is to go to their website and then try to figure out the anatomy of the web page, and then using that to write a code to parse the information that you're looking for. All right, so that was the second technique that I wanted to show you today. The last one, the third one, is how to use APIs. So in fact, for APIs, Uh, there's nothing much I can teach in a class because APIs are all kind of different. From Twitter API to Facebook API to whatever API you're looking for, they have their own kind of an ecosystem and everything, and they have their own syntax. And so a lecture is not really suitable to teach you how to use all of those different APIs. You will actually need to spend quite a bit of time studying the user documentation and things like that in order to master an API. But I thought it would be good to show you a gist of how dataset APIs work. Okay, so there are many dataset APIs. Like Twitter API is probably one of the most popular APIs for data mining. Um, you know, in fact, web scraping is not the favorite activity from the perspective of people who's maintaining web servers, right? I mean, imagine everyone is somehow sending a script like this and then try to retrieve information. And then that actually causes a lot of traffic, right? And with a script, I can generate millions of clicks per second, right? And then if I have multiple computers, obviously, then I can generate lots of click streams into a certain website. And obviously, that is going to slow down the server. And then the other innocent users, quote unquote, will be affected, right? So from the perspective of people managing the web page and managing the server, and those are not the favorite activities that you want to see. And there's always a risk of security and all sorts of that. So, like big companies like Twitter, oftentimes they're a target of web scraping because a lot of people are interested in analyzing what kind of hashtag is most frequently mentioned at this point of time, and so on and so forth. A lot of people are interested in Twitter data. So instead of allowing them to freely scrape the information, Twitter actually has came up with this API library, which is a set of Python codes that allows you legal access to Twitter web content. Okay, and they even have some pretty useful predefined function that you can use off the shelf. Similarly, in Facebook, Facebook is also a popular target of data mining. And instead of allowing all sorts of illegal traffic, what they did was to develop an API where they permit a legal access to Facebook contents, by giving people a predefined set of functions. So that's kind of what the dataset APIs do. In this tutorial, what I'm going to show you is a Yahoo Finance API. Because Twitter and Facebook APIs, they actually require you to be a verified developer. So in order to use Twitter API, you actually need to submit an application to Twitter, and then Twitter is going to review your application to see if you are an innocent developer or some malignant user who wants to do something bad. And they're going to review your application, and then only when you're approved after the review, you're going to be granted an access to Twitter API. So I thought that was not very good for a course. Of course, you are encouraged to try it out, and Twitter API is actually quite exciting. You can access a lot of different information. But in this class, I will use Yahoo Finance API instead, because Yahoo Finance API, in contrast to Twitter API or Facebook API, there's no registration process. Yahoo Finance API can be installed using pip install Yahoo _fin. And in fact, Twitter API, Facebook API, those are pretty similar. You can similarly install Twitter API and Facebook API. So the only difference is, getting a developer permit. Now, after installing the Yahoo Finance API, what you can do is then to import Yahoo underscore Fin library, and then there's a particular model that is useful, which is called the stock underscore info. And I'm going to give an alias to this module because it's kind of painful to type all this, stock underscore info all the time. So I'm going to just shorten the name as SI. Yes. Well, in order to use Yahoo Finance API, request HTML library is needed. So actually, I forgot to install that. So I'm gonna just create a new line here. Pip install requests underscore HTML, and that installs the requests HTML library. And then after that's done, well, there's an error about URL lib, but I don't think it's as significant, so I'm gonna just ignore that. Now I don't see that warning anymore because I just installed the request HTML library. Now the stock info module under Yahoo Finance library is quite easy to use. You can just call get underscore data, and then you can type a ticker. So let's say you're interested in Apple stock. That's going to be AAPL. By the way, if you're not so familiar with the US stock market, you could visit finance.yahoo.com, and here you can see that the stock price movement in real time. Apple Inc. has a symbol of AAPL. There are a couple of things that you can try, like Netflix, which is NFLX, Tesla, TSLA, NVIDIA, I think NVDA, things like that. So I don't memorize all, symbols, but I only memorize the ones that I am interested. And you can actually explore that information from Yahoo Finance webpage. So in this example, though, I'm going to just use the Apple as an example. So si.getData is a function to retrieve an information about that particular stock. And for example, if I print data, then as you can see, I have an information about this Apple stock from 1980 to the current date. So I'm recording this video on October 6th of 2020, and as you can see, the daily stock price movement from 1980 to the current date. Actually, I'm recording this video on October 7th, but it's way before, well, it's a few minutes before actually the stock price, the stock market opens. So, but yet it's not, the market for October 7th has not opened yet. So that's why we don't have information for October 7th. But I have pretty much everything that I need over here as a result of getting data from stock info library. You can, of course, specify the start date and the end date. So let's say I'm not interested in the data in 1980s. I'm in fact interested in from January 1st of 2019, and then I'm only interested in start underscore date, and then end underscore date, December 31st, 2019. So I am interested in the stock price data for year 2019, and that's the command that I can use. So obviously January 1st is a holiday, so there's no stock market, and December 31st, I think it was Saturday or Sunday or holiday. I cannot remember, but that's why we don't have that particular date. And in fact, the numbers are not continuous because We have holidays, Saturdays, and Sundays, and because of that, only the dates when the stock market was open is available in this table. But other than that, that's basically how you can use SI, the stock info module under Yahoo Finance Library. Now, if you want to access a particular rows, or you can call data.index. Again, this is a specific syntax to Yahoo Finance Library. It doesn't mean that you can do the same thing with Twitter API or other APIs. It's just particularly for Yahoo Finance API. But under that Yahoo Finance API, data.index is a way to retrieve all the row index of the data. Similarly, data column name dot values is how you access the values of the columns in the data set. So let's say I'm interested in the open price of the stocks. Then data square bracket open values is how you retrieve the open price. So it started from $38, $38 over here. So you can see that the opening price of the stock price is displayed like this. In case you're interested in multiple columns, you could do something like this. So instead of just an open price, I also want to know the closing price of the stock. Then there you go. You can use the double square bracket. So inside of the square bracket, you can use a square bracket to provide a list of the column names. And as you can see, now we have a table of 2 columns. So that's essentially how you can use stock price data. Now, this is, this data that stock info library returns is obviously not Spark data frame. So if you, let me close this. If you, for example, print a type of data, then you will realize this is actually a data frame defined under pandas. So stock info library uses a library called a pandas. Pandas is actually quite popular library for handling data tables in Python. But this is not the same as Spark data frame. So there's got to be a little bit of conversion. Okay, so in case of pandas, conversion from pandas data frame to Spark data frame is actually quite simple. But I think, at this point, you will understand, you'll have a clear idea of how to convert this data table into Spark data frame, right? So what you need to do is basically to write a script to, create a Spark data frame, and then basically migrate all the rows into that Spark data frame, okay? Which is, I'm not going to show in today's lecture, okay? Because it's quite straightforward. So that's it for today. I hope all these 3 techniques that we covered today, including the Kaggle API, the public data set, and then the data scraping method, and then finally the API method. I hope those techniques could be useful for you guys. And of course, this course is not supposed to cover all the techniques that exist outside. There are actually many data mining techniques and data APIs and things like that, and it is impossible to cover that in a course. And data mining is certainly an area where kind of hands-on knowledge and know-how is more important than science per se. Okay, so what that means is it requires a lot of practice and a lot of experience to become a better data miner. With that remark, I'm gonna end this video. If you have any question or comments, please feel free to leave it in the comment section, or leave that on icon discussion. Otherwise, I'm going to see you in the next class. Thank you very much.